Hey, how's it going? My name is Ethan Geller. Um, and I'm sorry that I can't be there. Procedural Audio Workshop is an incredible lineup. It's an incredible group of people. Due to concerns about COVID, I ended up staying home and doing this remote and pre-recording this talk. But I hope to make it up to you with some pretty cool content and some stuff that I've been working on. So yeah, let's get right into it. So, name of my talk is actually Faust Metasounds and the Next 10 Years of Audio Compute. If you don't know what Metasounds is, totally cool. We'll talk about it coming up. But it's the audiovisual programming language used in Unreal Engine 5. It's new to Unreal Engine 5. It's really cool. And first off, why would I talk about it? Well, I worked on it for about a year before leaving Epic. Real quick background, I met Ramon at GRAME. When I was hanging out around EarCam, the guy that Tom Mays told me about GRAME and Faust and how cool it was. And it was really exciting to check out and really changed a lot of my opinions on how audio DSP could be expressed and deployed, right, in new and interesting ways, just the way that audio software could work. So after that, I ended up hanging out with Ramon for 2 more years at Karma as a grad student, and worked at a few places. I worked at PlayStation on some spatialization tech, also worked at Dolby, and then for 3 years, worked at Epic, worked on the Unreal Engine, worked on a game we created called Fortnite, and for kind of my final year there, worked on kind of the early stages of Unreal Engine 5, which is now available for early access and has some really incredible things in it, including a new visual programming language for audio signal processing called Metasounds that we'll talk about. These days, I'm actually at what was formerly Facebook Reality Labs, is now Reality Labs at Meta, working on audio technology and research for audio compute. But in general, if I can sum up my career and my experiences and the things I'm interested in, is first off, goofy photos with Chris Angel. Second off, it's audio compute and audio processing, right, in a way that makes expressive idiomatic DSP graphs easy to deploy, easy to compile, easy to optimize, right? And from that, I fundamentally believe that good tooling that will make that compute and the consideration of that compute transparent, that will then allow technical sound designers, right, digital signal processing professionals implement things that could then be deployed using the tooling and platforms that I've created. So why do I love Faust? Faust was hugely influential when I first saw it, and still a hugely influential part of my brain today, right? And one of the big things is that there's no runtime actually required, right? You may be familiar with something like libfaust. Libfaust is actually a compiler that will dynamically compile Faust code to LLVM, to an intermediate representation that could then be run or lowered to machine code, right? But Faust is a compiled language. You can do static compilation and do a lot of really cool optimizations because of that static compilation. Obviously, the syntax is incredibly precise. It's super quick to iterate on. You can really easily move around these kind of different components of your DSP graph, capture them in macros, and kind of compose them. It's incredibly performant, right, because it's easy to vectorize ahead of time, because you can really explicitly create these kind of feed-forward systems that we can be really optimistic about. And as you've probably seen, it can really deploy anywhere, right? You can make a VST from a Faust object. You can deploy this thing to a mobile phone, to the web, right? To WASM. That's incredible. But this all really boils down to one really great decision, right? And it's creating a compiled audio data graph designer for synchronous data flow systems, right? Where you can really express a topology that is directed, acyclic, with the exception of delays to bring audio back and create feedback systems. And that actually allows you to, as a compiler of that language, do some really neat performance optimizations and actually deploy this thing to arbitrary targets using whatever compiler backend you want. And Faust is kind of, it's not necessarily the first language to do that, right? Clang and LLVM has really opened the door for this thing for Rust, right, for compiled Python. But Faust is really cool because it's kind of the first time I've seen kind of low-code signal processing tool use Clang to the full extent that Faust does, and really benefits from it. So I think about Faust a lot because of that. And because of that, right, in kind of early design decisions for Metasounds, right, it was a team effort. There were a lot of people involved in this, right? Phil Pop, Aaron McLaren, right, Maxwell Hayes, a lot of great people, Rob Gay. But anytime I had like a design opinion, almost always it was heavily inspired by Faust, right? Just the idea of having a compiler for this graph, right? Something that could do a topological sort, right? Synchronous data flow was important, right? Really saying, hey, if we make these things acyclic for sample n, right, with the exception of feedback systems, which are explicitly happening later, are being cached and buffered and then retrieved in the next compute cycle, we can do a lot of really cool things, the kind of things that Faust can do, right? So in many ways, Metasound is like a Faust-like, as I like to call a language, but with extensible types. And those types get you some really cool stuff, right? They get you, let me not get to that slide yet. The types get you things like sample accurate timing, right? So for example, there's these concepts of triggers, right, in Metasounds. And you can just like trigger at the beginning of a render quantum, like every 5.3 milliseconds or what have you, depending on your buffer size and your sample rate. You can, fire off just like, oh, I press this button, right? I played this note. The note begins, right? The oscillator starts, what have you. But maybe you want that thing to be sample accurate and scheduled and synchronized with like a really precise sample accurate event. In order to do that, well, it's the same type. We can just extend that type and allow for an array of multiple triggers, and with the potential of each of those triggers having sample offsets, right? So you can actually have, okay, simply because we have the structured data type for trigger, instead of just having a Boolean that's like, oh, we have triggered this input or not, we could say, oh, this input is triggered 30 samples into this callback, right? And because of that, there's some really powerful things you could do with Metasounds for music scheduling and for really sample accurate things that really pay off a ton of dividends. This is a big problem in games with stuff like automatic weapons, right? Where it's like, oh, the frequency of this sound effect, we can't let it get quantized to our buffer callback. So sample accurate scheduling allows those things to really be possible and to not sound jittered. So there's one big drawback, right, with that. And it's that Metasounds then becomes a slightly less, quote unquote, pure language, if that makes sense, than Faust. So Metasounds at its base layer is a node language and a topology that you design, but those individual nodes at the lowest level are implemented in C++, right? They're, created with there are these functors that are created with these inputs and outputs and registered, and then there's a function callback for that functor, compared to something like Faust, right, where all these objects that you're using and reusing in the library are actually macros, right? They're actually these systems that could then be broken down into smaller macros until at the very lowest point it's all adds, multiplies, and delays, right? So in that sense, like Faust is a really pure signal processing language. Metasounds is much more impure, right? Because the library is ostensibly implemented in C++. This was a deliberate trade-off, and it was worth it for Metasounds. Yeah, C++ interop is really like the killer story of Unreal. Being able to write C++ and recompile it on the fly is one of the big features of an engine like the Unreal Engine. So, creating these kind of C++ functors and exposing them to designers in the editor is like kind of Unreal's bread and butter, right? There's a similar VPL for general game scripting called Blueprints that has a very similar methodology. So this is idiomatic to Unreal, and it's the route we chose. But it brings into light this kind of interesting question, which is can we actually generate Metasound nodes from a Faust script, right? If Faust has a synchronous data flow that we've kind of deployed, right? And Metasounds are kind of similar to the compute model. How do we get them to interoperate in a little bit better way? So the first kind of brute force method I was thinking was I'll take libfaust and I'll just kind of package it into a plugin for Unreal, and it'll just be kind of like a Faust node, right? It's a node implemented in C++, right? And you just give it what Faust script you want, and it'll just compile that on the fly using libfaust, using Clang, using the full compiler toolchain, and yeah, then just invoke the compute callback for that thing. And initially this was an interesting route, and I ran into some serious drawbacks with it. One big thing is, you notice that there's these kind of types for all these Metasound nodes, right? And these kind of like very specific inputs, right? There's no real good idiomatic way to say like, okay, this Faust DSP object has these inputs with these types, right? One big thing that's cool about Faust is all those inputs, you declare them as part of a UI, but then they all get baked down into like these float parameters, right? that you can then sample and then use arbitrarily inside the process callback. It also kind of made it difficult to debug, right? I was trying to figure out why something was going wrong in my Faust object, and it was hard for me to tell if the issue was the host, right, C++ that I was writing, or something in the Faust object itself, right? And it kind of led to this problem of like crossing the streams with compilers, right? There was, say you're on Windows, right, and you want to use MSVC and you want to debug in MSVC, but now Faust is using Clang to compile, and you have this kind of like multiple compiler story. That was really unappealing from a software architecture standpoint, right? So during this, right, I came up with something kind of a little gross, right? Because Unreal already has this really idiomatic story for compiling C++, what if we generated some C++ from the emitted C++ from the Faust compiler and actually used the hot reload function for that? So that's what I kind of ended up doing, right? There's a plugin, right? So the actual Faust Metasound Unreal plugin, instead of packaging libfaust, it's actually generating a new plugin with injected C++ from a Faust compiler that could be anywhere, right? It could be the remote compiler, it could be from the IDE. And at that point, when we import that actual Faust object, right, that's actually getting injected directly into a C++ file. And then using some template metaprogramming hacks that I've used, I'm able to create a prototype of the Faust object, build the UI, and kind of glue that to declare some inputs, right? And outputs based on how many audio channels there are. And using that UI builder actually allows us to get some stuff like, like names for these things, right? Some limits, right? What's the initial value of this thing? And then that generated C++ ends up getting hot compiled, right? As soon as you import it, and as soon as we've kind of copied the file in, parsed it, injected codegen of the entire module, we're able to recompile that module and immediately use that Faust object without restarting the editor. And yeah, maybe I showed that to you. So let's just go to the IDE. Faust IDE. Yeah, Faust IDE.gram.fr. Yeah, so I was looking at the wind object, single flow parameter, of course. Perfectly solid. So let's export this. Let's export the C++ from this thing, right? So we compile it. We got a QR code. We download it. I'm going to open this thing, and I'm going to extract it, right? And we've got the generated CPP here. If you've used the Faust IDE and emitted C++, you've probably seen something like this here before we get there. So I do have a widget. I was working on this widget all night last night, hoping to get it done, and I wanted like a file drag and drop here. Haven't quite gotten that done yet. I'm not a UI programmer, fun fact. I'm really bad at anything having to do with UI. But I did create this quick little command, which basically does the exact same thing, right? And you just pass it the path. So this is called win.cpp. And yeah, gonna get back over here. And we're gonna import that buddy. So you can see already we've kind of imported it, and now we're compiling some C++ using the compiler of your choice. Okay, I'm gonna stop this and relaunch it. Uh, So when we hot reloaded and registered it, there is a bug still that occasionally it will run into a crash in the registration, which if I rebase to the most recent version of UE5, it no longer exists. Early access, but here we're going to create a new Metasound source here. And as soon as we pop this open, start seeing Faust dot and then objects that we've imported, right? And now you can actually see, I'll pop this over here, and I'll just set this to 2.0, right? Whoop. Too much force. Too much force. Too little force. Ooh. Okay, anything above 1 I think is unstable. So let's try that. Yeah, there we go. And then these literals, you have to restart to use them. But yeah, we could pretty much do that with anything. So I've imported a bunch of these, right? And you can see that there's like, if you look at these, there's actually types here, right? Based on what you've actually seen. So things that would be like toggles or buttons look like toggles here. Floats look like floats, etc. And yeah, something like this, right? We can actually, you know, mess around with. I'll just type in some random parameters here. And actually route as you see fit. So the actual import process, besides that bug, which yeah, I'll fix when I finally rebase it, but is avoided by just restarting the editor. You know, it worked out actually a little bit better than I was expecting. I was expecting this to be horrifying, super hacky, should not actually work. But yeah, individual UI elements end up actually corresponding pretty well to like different types, right? Like you've got a slider, and that could be a float, right? Or, oh, I've got a toggle switch, and that should be a bool, right? So there is kind of like this idiomatic transfer between Faust and Metasound in that way. The actual compilation, the recompilation and generation of the code was way quicker than I was expecting, which was really cool. You can actually step through it in the debugger, which is really good for me when I'm trying to iterate and mess with code and extend code that I originally started in Faust. I could use whatever IDE I want or environment I want for these Faust objects, right? So I could use a web IDE, which is really cool and appears from my perspective to be quickly becoming like kind of the de facto development environment for Faust. So able to use that, able to use the previewing mechanisms in the Faust IDE. And those generated Faust Metasounds are actually, plugins are actually really easy to just zip up, right? So everything that we created here through this import Faust, you can actually see when you go into the products plugins folder, you actually see a generated plugin, right? This can actually be zipped up and packaged and distributed to people, and is a whole library of Metasounds that you created originally from Faust. I think my goal before I actually ship this as like a PR, right? Before I call this quote unquote done, is to be able to essentially import the entire Faust standard library, or as much as I can get in there, and try to zip that up as like a Metasound library, ostensibly. So yeah, so I'm gonna send out a Google link with the actual plugin in a directory, like very early, like literally just made this like last weekend when I was like, oh, I want to do this talk. So, you know, try it out, but buyer beware. And I'll have some light text, and I think during my workshop I'll be able to describe how to use it a little bit better. Yeah, I've only got really 2 or 3 more things beyond that that I want to work on, just fixing up that UI, fixing up that file drag and drop, and yeah, being able to query the remote compiler so you could actually pass a DSP and get C++ back without running the compiler client side. So that's pretty much it. I got one last thing I wanted to talk about, which is the next 10 years of audio compute, right? This is something I think about a lot. This is a lot of what I think about at work and what I've thought about at previous jobs. Like the coolest part about Faust, in my opinion, is that it really sets the stage for a generalized audio shader model. If you've ever worked with shaders, right, in the realm of graphics and render, like the idea is essentially you write something in like a front-end language, like HLSL, right? And that gets compiled to some IR, right? Be it SPIRV or DXIL, right? There's some intermediate representation that is kind of a compiled sort of functional application of that thing that then gets deployed to the client-side computer and then compiled, lowered to proprietary kind of like a GPU assembly languages. And this is great because the shader itself, like backwards compatibility doesn't break. And someone like NVIDIA, as they make new and more novel GPUs, can arbitrarily extend their instruction set at the assembly level as long as they don't break backward compatibility with this high-level intermediate language, right? It successfully kind of decouples iterating on hardware with iterating on software in some really cool ways that, in my opinion, allow for even better collaboration than just like a fixed function top-down pillar where someone who is using the GPU would request a feature and then the person implementing it on the other end would just give them a function. So yeah, so you could imagine something like Faust compiler toolchain through Clang to be generalized a little bit higher level, right? So that something could be just a generalized audio topology, right? A node graph. And then we have this kind of intermediate representation, this high-level intermediate representation for just here's what like nodes look like, right? Here's how you connect nodes in a graph. And then there's a compiler that just emits LVMIR, right, through Clang and then goes through the compiler toolchain. And there actually is some really cool novel work for that being done in machine learning right now for stuff like PyTorch, right? So MLIR, Chris Latner, the guy who created LVM and Clang during his time at Google, created this kind of a multi-level IR framework that allows for different dialects and different disciplines of specific intermediate representations for software. Things like ML compute, like DAG, stuff like linear algebra, right? That would allow for really easy lowering into like new and novel hardware targets, right? And you can see this being really useful for audio. So the TLDR of that is like, what does that mean, right? It means that in the future there could be an open source standard for an audio shader model that would allow for interoperation between like Faust, Gen, Metasounds, any kind of compiled audio programming language, right? And allow them to actually interoperate and inline into one another, right? You can see like a Faust object like this being inlined into Metasounds. You can see a Metasounds graph being inlined into Gen, etc. And then being able to lower all these languages to this IR amount allows us to deploy it to literally anything, right? It doesn't have to be ARM or x86 as these instruction sets are in this diagram. It could be the web, right? It could be like a Shark DSP chip, right? It can be something that previously was only feasible for like a company like Universal Audio, right? Could be feasible to the general public, right? And that's really empowering and that's really cool. And I think that that's the future of audio render that we have to implement as a group, so as a community. So thank you for coming to my talk. Sorry that I couldn't be there. Hopefully this video is solid, and I guess I'll see you for the workshop. Have a good one.